Hello, so this is your Monday asynchronous lesson for algebra. This is going to be 7.3 multiplying polynomials. So you need to write down all the examples. You're going to see multiple ways you can multiply binomials by trinomials, binomials by binomials. There's not one perfect way to do it. So after this lesson, pick whichever method makes the most sense for you, and that's what you should go with. Myself or Mr. Sansoni, we will never ask you to multiply it in a very specific way. We'll just say to multiply the polynomial. So pick whichever method you want after today and just go with it. So the learning objective of our iWillBot is just multiplying polynomials, whichever method you feel like it. We're just gonna just get going here. So our very first method, I'm calling this the traditional and I'm calling it multi-term multiplication. The best way to relate this to something that you already know is like two-digit multiplication. So if I had asked you to do 21 times 48, there should be no one that doesn't remember what to do. And so that's what I mean by traditional multi-term multiplication, because this is technically multi-term. There's more than one digit. And so the first method of multiplying binomials is traditional. So right now I have this expression x plus 2 times x plus 5. It's in parentheses to represent that x plus 5 is like one thing and x plus 2 is another thing. So when I set up my multiplication for this, it's okay to drop your parentheses. So I'm just going to take my first term, which is x plus 2, I'm going to put that on top, kind of like my 21. And then I'm going to line up my other terms, x plus 5, right below it. And then I'm going to do a little multiplication symbol, really tiny x over here. And then we would treat it just like we would a multiplication problem with just numbers. So I'm going to start with 5 times 2, that's 10. The only difference between this kind of multiplying and a normal digit multiplication is that we will not carry anything. You know, if I did 2 times 5 on a normal multiplication problem, I would carry a 1. We don't do that. You just put the number as is. Then I go diagonal and I say 5 times x. Well, that's 5x. 10 was a positive number, so there's going to be a plus sign in between. Now I go to my second line, because it's like a second digit, and we would need a placeholder. And then I start with x times 2, which is 2x. And then I go straight up and I do x times x. Well, remember that this is kind of rules of exponents that you learned last year. X times x is the same thing as x squared, not 2x. With this, all of our numbers were positive. I didn't have any negative numbers, so I'm going to put plus signs in between. And just like normal multiplication, what happens now is I add straight down, and we add our like terms. So I add the constants, the single variable, and the terms that have an exponent. So 10 plus 0 is 10, still positive. 5x plus 2x is a positive 7x. And I don't have another term that has an exponent of 2, so this is really a placeholder here of 0. And 0 plus x squared is x squared. Please make sure that you write your final answer in standard form, which ours is, because from left to right the exponents go down. So I'm good. That's our first example of traditional multiplication. Now you see I have 3 examples here. I will also do B, and then I want you guys to pause and you will try C. So I'm going to move on here to B. We have x plus 9 times x minus 3, or sorry, x minus 4. I'm saying times because you remember multiplication, that symbol is one of the things that we don't really like to write in math. It's usually represented by 2 things being glued next to each other, so that's how I know it's multiplication. So the first thing I'm going to do is drop my parentheses and line up the terms top to bottom instead of left to right. So this is going to give me x plus 9, and then below it, x minus 4. And I'm lining up my terms. Double mini multiplication symbol over here. So I'm going to start with my constants. Negative 4 times positive 9. Well, negative times a positive is a negative, and that's negative 36. Going diagonal. Negative 4 times x is negative 4x. I don't need anything else in between my negative 4x and the minus 36. The negative sign is really acting as my subtraction. It's my placeholder in between, so I can just leave it as is. Now I'm going to add a placeholder because it's like 2-digit multiplication, and I'm going to go diagonal. And I do x times 9 Well, see, that's just positive 9x. I put a little plus sign here in between the 9x and the 0. It's really not necessary because 0 is not really there, but it just helps me to fill it in. Now I'm going to go x times x. Now rules of exponents say that's x squared. The 9x was positive, so I put a little plus sign in between. From here, I'm going to add straight down with my liked terms. Negative 36 plus 0 is negative 36. Negative 4 plus 9, well, this is a positive 5x. And there isn't another term that has just an x squared, so it's really a placeholder here of 0. And I'd have 0 plus x squared, which is x squared. So hopefully we're starting to see kind of what we have here. We have x squared plus 5x minus 36. Now I want you to try one. Try the traditional method and then I'll show you the next one. So you have p plus 3 times p minus 4. At this time, please pause the video, work it out, and then unpause to check your answer. Okay, let's see how you did. So I'm going to drop my parentheses. I have p plus 3 on top, p minus 4 below. Negative 4 times 3 is negative 12. Negative 4 times p is negative 4p, placeholder of 0. P times 3 is a positive 3p, and p times p is p squared. Then we add straight down. Negative 12 plus 0 is negative 12. Negative 4p plus 3p, well, this is a negative, technically 1p, so I'll put it in the 1 for right now. There is no other term that has a p squared, so I'm going to put in a placeholder of 0, and 0 plus p squared is p squared. Now, this is an appropriate way to write your answer. You could keep this actual 1 in front of the variable p. It's not necessary, but it's not wrong, and so I'll show you can leave your answer like this, or more than likely what you'd see it as is p squared minus p minus 12. It's another way to write your answer. Both are absolutely correct. So you may go with whichever one makes the most sense for you. But hopefully that one went okay. This is only one method. Now I still have several more to show you. Method 2. I'm going to call this the box method. Now for me, like Ms. Horner, this is my personal favorite. The next method I'll show you is Mr. Sansoni's personal favorite. So again, you're just going to pick whatever method works for you, whichever one makes the most sense for you. For me, the box method, I really like it because it organizes my work, for one. And two, when I, Ms. Horner, teach factoring next week, you're going to see me use this method again. I just think it's a nice systematic way to do this. So what does it mean? Well, box means literally I'm going to draw a box. Specifically, I'm going to draw a square. Each term here, you see we have the binomial. Each term has two things in it, variable and a constant. This is representing like a length, if you will, and a width. So this is really length times width. And the number of terms helps me like divide my box up. So I'm going to let 2x minus 3 just be written at the top of my box. This is my length. Because there's two terms, what I would do is long ways or straight up and down vertical, I would split my box in half. So that, 2x is kind of holding up on the left side and the minus 3 is holding up on the right side. And then I go to my width, or my other term, which is x plus 5, and I'm just going to write that as my width. So I have x plus 5. Notice I'm writing it vertically because, well, if I wrote it, horizontally, it'd look funny. This also has two terms. Now, because this is the width, it means on the width side, so going left to right, I would cut my box again down in half. So you can see it's giving us 4 boxes. Now, in science, you guys learned Punnett Squares. This is very similar to a Punnett Squares. It's another reason it's a personal favorite because it's relating it back to another class. Now, within each little mini square, what happens is we do mini length times width. and we're going to find, the answer, and we're going to put it in the box. So if I start here in the top left, what I'm multiplying is 2x times x. So technically, I'm multiplying a length and a width of a mini box. So let me start with the variables. X times x is x squared. Then you deal with the constants or the coefficients in front. 2 times, well, when there's not something in front of a variable, assume it's a 1. So it's 2 times 1, which is 2. So in the top left box, I get 2x squared. Then I'm personally going to go down to the bottom left. What I'm multiplying here is the length, which is 2x, but this time I have a different width, which is positive 5. So 2x times positive 5, I only have constants, so 5 times 2 is 10. The variable tags along. So in the bottom left, I have 10x. Now let me move to the top right. I'm going to technically multiply the top little box, which is negative 3, times the side box of 1x. This is really just multiplying constants, so negative 3 times a positive 1 is negative 3. X tags along. Bottom right is always the easiest. It's literally just multiplying two numbers together. So a negative 3 times a positive 5. Negative times a positive is negative, and 3 times 5 is 15. Now, hopefully you notice that I have some like terms in the diagonal specifically. What you do is add your like terms. So when I do this, I write this, my answer, always in standard form. So I start with 2x squared. When I add my like terms, that's 10x plus negative 3x. That's a positive 7x. And what's left is my constant, minus 15. That is my final answer. You could have rewritten all of the boxes out, so I could have done 2x squared plus 10x minus 3x minus 15, and that might be an easier way for you to see your like terms, and that's fine. No matter what, you still get that same answer. Let's try another one. Again, this is still one I'm going to do for you, and then I'll let you try one on your own. Notice you're going to try every method on your own to see which one you like the best. So here I still have binomial by binomial. So I'm making a square. Well, how do I know I'm making a square? How do I know I'm not making a rectangle instead? Well, if I were making a rectangle, think about rectangles in the sense that your length is longer than your width. You do not have all four equal sides. Well, because both terms are binomials, that's like the same length. 2 terms by 2 terms. So that's why I know it's a square versus a rectangle. I'm going to let 3x plus 1 be on the top. There are 2 terms, so what I'm going to do is straight down, split my box in half. Now I'm going to go to x minus 4. That's my width. So I'm going to have x minus 4. I get asked a lot, how do I know which one goes on the top, which one goes on the side? It does not matter. Literally does not matter. Why? Well, multiplying is commutative, meaning I can multiply things in whatever order I feel like it, and I get the same answer. So that's why it does not matter where I put them. I just have a tendency to do this. Let's see, x minus 4, there's 2 terms, so what I'm going to do is lengthwise, or from left to right, I'm going to split my box again, technically in half. Now I have 4 boxes, that's 4 mini multiplication problems. I'm going to start at the top left. 3x times x, variables first. X times x is x squared. 3 times, what's not there? There's a secret 1. So 3 times 1 is 3. So you get 3x squared in the top left. Moving to the bottom left, 3x times negative 4. So let me just deal with those constants. 3 times negative 4 is negative 12. X tags along. Top right, 1 times 1x. Well, that's pretty easy. That's 1x. And the last but not least, bottom right, is the normal multiplication of positive 1 times negative 4. A positive times a negative is a negative, and 1 times 4 is 4. I tend to just look at the diagonal because that's easy for me to spot. I see that they are like terms because they are both just 1x. What I mean by 1x, I mean it has like just an exponent of 1. So I'm going to write this in standard form. And I'd have 3x squared first. When I combine negative 12x plus 1x, this is negative 11x, and minus 4 tags along at the end. I could have rewritten this as 3x squared minus 12x plus 1x, minus 4. And when I combine like terms, I still get the same exact answer. And hopefully you're seeing this is very similar to your Punnett squares in science. Now, let's try yours. Let me make a little more space here. So you have to multiply x plus 3 times x plus 4. Please pause the video now. Try the box method. Okay, so well, let's see how you did. So we got a box. On the top, I have x plus 3. There's 2 terms, so I split my box in half. Second is x plus 4. I'm going to put that on the side. 2 terms means split in half. And you're multiplying every little corner. So we have top left is x times x, which is x squared. Bottom left is x times 4, and that's 4x. Top right is 3 times x, which is 3x. And bottom right is 3 times 4, which is positive 12x. You should be able to see that you do have some like terms. So when you combine them, you'd have x squared plus 7x plus 12. No matter how you combine them, you could have written it out. Each box being written out on its own, and then combine your like terms. No matter what, you still get the same exact answer. Now, if you're starting to feel comfortable with any method so far, which is only 2 of them, that's great. You know, another way you can check your answer is if you multiply it using one method and then check your work with another method. So maybe you feel most comfortable with the box method, but you feel okay about the normal multiplying, the traditional method. You could do the box method, get an answer, and to check your work, you can use the traditional multiplication method, and you should get the same answer. It's just one way, you know, you can be sure of your work. Okay, this is now method 3. This is FOIL. I call this the formula method. Now, this is Mr. Sansoni's favorite, so you'll see him do this most often. I call this the formula method because it literally is a formula. It tells you step by step what to do. So FOIL is an acronym. Each letter stands for the step. So F stands for first terms. O stands for outer terms. I stands for inner terms. And L stands for the last terms. Now I put this starter note that says add all together. That means combine your like terms. So I'll give you a moment to get that written down, and then we're going to work through this together. So I like to list out the letters, F-O-I-L, off to the side. And this kind of just helps me organize my work. F stands for first terms. This is within each set of parentheses. What's the very first term you'd see, which is an X and an X. Now, the original problem is multiplying. So what I'm doing with these first terms are still multiplying. So my first terms are really X times X, which equals X squared. Outer terms. Well, that stands for looking at this expression as a whole. So the outer terms is what's on the far left, which is an X, and what's on the very far right, which is -6. And I multiply that. I am going to let my constant go first. I'm going to say -6 times X, and that's -6X. Outer means on the outside. So it's on the outer edge, X and -6. I stands for the inner terms. So that means like the innermost terms. So what's kind of the farthest inside you could possibly be, which would have been -3 and X. These are the inside terms. They're stuck in between things. So that becomes our next product, which is -3 times X, and that equals -3X. And the last terms mean within each set of parentheses, what is the last term? And those are your constants. So that's -3, because it's the last thing on the first set of parentheses, and -6, that's the last thing on the second set of parentheses. So you're going to do -3 times -6. Well, a negative times a negative is a positive, and then 3 times 6 is 18. Now we're going to pay attention to the star note that says add all together, combine like terms. So I'm just going to show a little addition symbol straight down. When I'm adding, my like terms only belong in the middle. It's technically the outer terms and the inner terms that are your like terms. Everything else does not have a like term or a partner here. So I start with x squared. When I combine -6x plus -3x, that's -9x, plus 18. You have to make sure your answer is in standard form, which I know it is, because from left to right, my exponents go down. And then I get my same answer. Now, I am not a formula person. That's my just personal preference. I just don't like to memorize things. FOIL is not the hardest thing to memorize, but if you're like me, maybe one of the other methods comes a little more naturally. If it doesn't, FOIL will always work. So it's a really great method. You use whatever you want, whatever works best for you. I'm going to go down to now to B. I am going to do this one again, and then I will have you try one on your own. So I'm going to start with FOIL. So I like to write out my letters because it helps me keep my steps organized. First terms means the first within each set of parentheses. That's 2x and 3x. So I'm going to say 2x times 3x. Well, here I can multiply my normal numbers or my coefficients, which is 2 times 3, that's 6. And then I can do x times x, which is x squared. If you're not sure why I was able to just kind of multiply it in that order, remember what I had said earlier, that multiplication is commutative, meaning I can multiply numbers in whatever order I wanted. And so just for the extra work, I could have rewritten 2x times 3x as, 2 times 3 times x times x. So I can kind of flip them around, switch places, and no matter what, I'd still get the same answer. So just in case you need to see why that worked, this was the commutative property. That looks like a U. It's supposed to be a V, not a U. Anyway, move on. Outer terms. So again, outer terms is referring to the entire expression. So very, very far left, which is 2x, times very, very far right, which is -5. I can multiply my numbers. 2 times -5. Negative times a positive is a negative. 2 times 5 is 10. X tags along. All right, inner terms. The inner terms are literally the innermost terms. So what's stuck in between, which is -1 and 3x. Well, a negative times a positive is a negative, and 3 times 1 is -3. And my x tags along. Keep on going now. Last part is the last terms. This is the last within each expression. So that means -1 times -5. 2 negatives make a positive. 1 times 5 is 5. You add everything together, which means combine your like terms. So I don't have anything but a 6x squared, so he just gets rewritten. -10x minus 3x is -13x plus 5. And that's your final answer. Let's try yours. I need a little more space. So here is C. This is the one for you. Try the FOIL method. And then after this, you can pick whatever one you want. So pause the video now, try it, and then unpause to check your work. Okay, let's see how you did. First terms means first within each set of parentheses. So 4n times 2n, you should have gotten 8n squared. Outer terms means the outermost, so that's 4n and 5. So you do 4n times a positive 5, which is 20n. Inner terms are literally the innermost terms with stuck in between. This is -1 and 2n. That gives you -2n. And your last terms means the last within each set of parentheses. -1 times a positive 5, and gives you -5. You should have been combining your like terms, adding everything together, which is really just your outer and your inner, and write your answer in standard form. You should have gotten 8n squared plus 18n, because it's 20 minus 2, and minus 5. So these are the three most common methods of multiplying binomials and polynomials. I should say binomials, specifically it's polynomials. You can pick whatever method works the best for you. Now, we still have another example. It's because you're still going to see some other types of multiplying. Now, what we've been doing is a binomial times a binomial, meaning 2 terms times 2 terms. Now, that's not exclusive. You know, you can multiply anything. So, we're going to practice, no, this is the last one. We're going to practice multiplying a binomial and a trinomial. Now, I set it up for you. And that just kind of works for me. So I thought it was nice to just give you a shot at it. You can pick whatever method, works best for you. I set up every single problem just so you can see it. So a binomial times a trinomial means something that has 2 terms times something that has 3 terms. So let me just talk about the setup of the problems, and then I'll have you pause the video and you can try. Pick whatever method. Pick one method and do it. Traditional. Now, think of this when you don't have, an equal number of terms. Think of it like when we normally multiply or add things or subtract things. We usually put the bigger number on top and then the smaller number. So similar here, I put the term that has the most, I put the expression that has the most terms on top, and then below it is the term that has the smallest amount of terms. So you could go with this and then multiply like normal. The box method. Now, because this was not an equal number of terms, I actually chose the one that has the most terms, so the trinomial, to be the length of my box. And because there's 3 terms, you can see I split my box into thirds. I shouldn't say threes, it's inappropriate, thirds. My second one had 2 terms, a binomial, so that's why I split it just kind of down the width-wise in half. So you actually have a lot more boxes. You have 6 boxes you now have to multiply if you're using the box method. The FOIL method, I feel like it just gets a little more complicated because you have multiple inner terms. So that's kind of what I set it up for you. So your first terms was your x times your x squared. Think about rules of exponents here, guys. Your outer term, you don't have a lot of outer terms, so you only have x times -2, and I rewrote it to make it look nice, to be -2 times x. It's the inner terms that's really the issue, because it's kind of like a distributive property. So I had to do 5 times an inner term of 5 times your x squared, 5 times your -3x. You can kind of see I needed multiple combinations of things to get my correct amount of terms. And then your last term, the last within each expression, so that's 5 times -2. So you have 3 options here. Pick one, whatever you want to do, you do. Multiply it, combine your like terms, and then when you're ready, unpause the video to check your answer. Okay. So I'm not going to show the work for every single one because no matter which method you choose, you should be able to get the exact same answer. So I'm just going to show you what that should be. So your final answer on this one is x cubed plus 2x squared minus 17x minus 10. If your answer is not written in standard form, you need to rewrite it. It is appropriate. It is the way you write your answers. And if you don't, we're going to take off points when we have a test or quiz. So from left to right, make sure your exponents go down. So you see I went from 3 to 2 to technically 1 to 0. And that is it. So there's at least 3 of the most common methods for multiplying. If none of these worked out, reach out to your teacher. We know other methods. We can help you out. Let's talk about your homework. This is true for everyone, whether you're in Mr. Sansoni's class or whether you're in Ms. Horner's class. So we have a Delta Math homework assignment. There's actually 2 parts to it. So the first part, you need to get 10 questions in a row correct. And then on the second part, you need to get 5 questions in a row correct. Please remember that if you don't, then you can keep doing questions until you do. With this one, you cannot have this turned in late. The reason is because this is due on Friday, February 5th. That is the last date, Mr. Joyner's mid-quarter due date for everything. So you need to get this in on time. If you're struggling, reach out to your teacher, go to a WebEx meeting, we can help you out. But this work, we are not accepting late. So get it in by the deadline, reach out if you have problems, and that is it. So go work on your homework and have a great day.